And I'll put this up on the screen. Just give you all something to look at, get you started. Caden's with a 5. He's just got to chill here this afternoon. There's Mary. Come on in, Mary. What's your mood today, folks? Where are you at on our wheel of mood? I decided that's what I'll call it. The wheel of mood. All right. Well, we'll close that out of there. We're going to look at our curriculum here, get us all started. Other people, they're going to be late. They can just join us on the run, I guess. We got to get some algebra going today. We got some new stuff to look at. New stuff today. All right, let's see. This is third hour right there in the middle. Let's go to our grade screen, see what things look like. Okay, Module 5. We did that a while back. We just got through with all the matrices. So you should have finished up the matrix quiz 2. That was it. The matrix quiz 2 is all that was due yesterday, but that was the very, very last of the matrix assignments. So if you're missing any of these matrix assignments, go back and get those done. 20 points. A lot of people getting 100% on these. A lot of people are raising their grade because the lessons step you through it step by step. So you should be able to go back and get 4 out of 4 on all of those, get 100%. So if you don't have 100% on any of those, go back and redo them. Use them for your advantage, all this matrix stuff. But we're through with that. As you can see, this week we have 2 assignments. We have simplifying rational expressions and discontinuities of rational expressions. We're like, oh, that sounds serious. No, it's not bad. But let's go take a look and see what it's going to show us today. All right, so go in here. I'm going to close the whole matrix thing. We're done with all of that. Closing the matrix folder, opening up the rational equations folder since we have moved on. So if you're done with that, close those folders out, simplify your screen. All right, 6.01, simplifying rational expressions. All right, starting with a strong foundation. Right? If you want to build a strong house that will stand the test of time and the elements, it's got to have a good foundation. You've heard that. So now it's time to build a strong understanding of rational expressions using the foundations of fractions and factoring polynomials. Neither of those things are new to you, but we're going to use them more in this unit. So after this lesson, you'll be able to answer the following question: how can rational expressions be rewritten in a simplified form? We like it when we can simplify things. So this is going to be good. Using fractions, that's a great place to start. Rational expressions are simply fractions that have a polynomial in the numerator and the denominator. See this, like 5x plus 35 over 5x. They still work just like a fraction does. So if you find yourself stuck, just think about how you would simplify or solve using fractions, and it works the same way. Just because it's a polynomial doesn't matter. So a rational expression is a fraction that has a polynomial in both the denominator and numerator. X squared minus 6x minus 27 over x minus 9. That's just a fraction. So think about the fraction 4 over 8. 4/8, right? If we had 4/8, we would not leave that as 4/8. Because when we look at that, we think, oh, there's a simpler way to write that. Start with 4 over 8. The numerator and denominator can both be factored. They're both divisible by 4. So we would factor a 4 out. Like we can click here in a little bit and show you. See, the top of the fraction is 4 times 1. The bottom of the fraction is 4 times 2. So 4 over 4 cancels out because 4 divided by 4 is just 1. So it simplifies to 1/2. Right? So we wouldn't leave 4/8 as 4/8. We'd simplify it to a half. All right? Did that match the answer in your brain? Were you thinking 4/8 was a half when you saw that? Did that just click? Hopefully that just clicked when you saw 4/8. So all you got to do is just factor that out. Well, this works the same way with rational expressions. All right, so factors are the numbers, variables, or the combination of both that multiply to be a product. Like 5 times x is 5x. So 5 and x are both factors of 5x because that's different pieces that multiply together to equal 5x. If we look at this one, 6 plus x times 1 minus x equals 6 minus 5x minus x squared. 6 plus x is one of the factors. 1 minus x is another factor. So those are the two binomials that you'd multiply together to get this trinomial. Right? Then we look at greatest common factors. Right? When you had 3w squared plus 27w plus 15, you can recognize that all of those are divisible by 3. So we can factor a 3 out to the front and make that simpler. Now it's just 3 times, parentheses, w squared plus 9w plus 5. This is simpler to look at and understand than this one is. All right, then we had the difference of squares. Remember, we had a squared minus b squared, and that's the same as a plus b times a minus b. Time to refresh ourselves on that. If you still have those notes, this would be a good time to use them. X squared minus 9 is the same as x plus 3, x minus 3. You know, just factoring with the difference of squares. The perfect square trinomials, we studied this as well. If we have a squared plus 2ab plus b squared, that's the same as a plus b squared. If it's a minus instead of plus, if we have a minus, it's a minus b squared. So, for example, if you have r squared plus 12r plus 36, that's just r plus 6 squared. That's a perfect square trinomial because it's r plus 6 times r plus 6. Or if it's a minus, it's r minus 6 times r minus 6. So that was the perfect square trinomials. Then we looked at factoring trinomials. Right? If we had x squared minus 8x minus 20, this is all review we're doing here, guys. So we'd have factors of negative 20. This is possible things it could be. Negative 1 and 20, 1 and negative 20. Negative 2 and 10, 2 and negative 10. Negative 4 and 5, 4 and negative 5. And then we add those factors up. We're trying to find which of those factors add up to be negative 8. Negative 1 plus 20 is 19. 1 minus 20 is negative 19. Negative 2 plus 10 is 8. That's close. But when we see positive 2 and negative 10, that gives us the negative 8. So then we know these are the numbers that it factors into. So it is then x plus 2 and x minus 10. Because the plus 2 and negative 10 multiply be negative 20, but add to be negative 8. So that was one way we factored trinomials. We also factored by grouping. Remember when we had like a 3x squared out front and a 4, that would equal 12. So we took the first coefficient and the constant at the end, multiplied them together and say, okay, what's the factors of 12? 1 and 12, negative 1, negative 12, 2 and 6, negative 2, negative 6, 3 and 4, negative 3, negative 4. That's all the different ways you can come up with 12 when multiplying two numbers together. And what do they add up to? We're trying to find something that would add up to that 8x in the middle, the 8. These add up to 13, these add up to negative 13. Oh, 2 and 6 adds up to 8. So we know we can rewrite this instead of plus 8x, we can write it as plus 2x plus 6x because that's the same thing as 8. Then we can group. Take the first two terms and group them together, and take the second two terms and group them together. In the first term, we can factor out an x. That leaves 3x plus 2. The second term, we can factor out a 2. That leaves 3x plus 2. So now with this term and this term, both of those have a 3x plus 2. So we factor it out, and that leaves x plus 2. So that was factoring by grouping. So we've done a lot of factoring. One more, sum or difference of cubes. Right? If we had a to the third plus b to the third, if you have your notes on this, you'll have that. That's the same as a plus b times a squared minus ab plus b squared. Or if that was a minus, then the binomial will be minus, and this first sign in the trinomial will be positive. So the binomial has the same sign as this, and the trinomial would have an opposite sign for the middle term. And they give you examples. X to the third plus 27. 27 is a cubed. It's 3 to the third power. So that would mean the factors are x plus 3 and x squared minus 3x plus 9. Or if it was an x to the third minus 27, it'd be x minus 3 and x squared plus 3x plus 9. All right, so we've reviewed our foundation. All right, this is all stuff we've learned earlier in the year. Different ways of factoring. Some of this was learned in Algebra 2. Some of it we even hit on Algebra 1. Nothing new, but does need reviewing. Let's look at page 3. All right, using skills on rational expressions. All right, I'm going to see how long is this video going to be. 3.5 minutes. All right, here we go. 3 minutes, 23 seconds.
Okay, we're going to look at some rational functions here. What is a rational function? Well, it's a function that's in the form of a ratio or a fraction. It's got a polynomial in the numerator, another one in the denominator. Sometimes, though, we can take these and simplify them a bit so that we don't have quite as much to deal with when we're trying to figure out some of the features of this function. So in this case, I don't see much I can do at the top right at the moment. At the bottom, it looks to me like I can factor an x out. So if I take out an x, I get x times x plus 2. Well, now I see that I can cancel this x with one of the ones in the top. So once I do that, I have 5x over x plus 2. I think that's as far as we can go, but that definitely looks a little better than it did before. Let's look at another function. This one's a little more complex. It is x squared minus 9 over x squared minus x minus 6. Now I notice that the top is difference of two perfect squares, so that will factor easily. That's x plus 3 times x minus 3. In the denominator, with a little checking, I find I can factor this as x minus 3 times x plus 2. Now I see I have a common factor of x minus 3 that I can take out. And now this leaves us with x plus 3 over x plus 2. And that's certainly simpler than it was before. Let's take one more. Let's take f of x is equal to 3x cubed plus 18x squared plus 27x, all divided by 12x squared minus 48. Okay? In the top, it looks to me like I can take out a 3x from each term. So 3x times x squared plus 6x plus 9. Now on the bottom, I believe I can take a 12 out. And so I get 12 times x squared minus 4. Now I notice this is actually a perfect square, and this is difference of two perfect squares, so I'll be able to factor those pretty easily. So we get equals 3x times x plus 3 times x plus 3 all over 12 times x minus 2 times x plus 2. Now I actually don't see any of these that will cancel. I do see over here in my coefficients, though, that I can take a 3 out of each of those. So let's go ahead and do that. And we get x times x plus 3 times x plus 3, all divided by 4 times x minus 2 times x plus 2. And maybe this didn't cancel very much, but we've simplified it as much as we can, and we've got it in a form where we'll be able to do some more things with it.
All right, so you see what he's doing? He's just simplifying it down to where it's easier to work with than the x squared or the x to the third or whatever you're looking at on there. All right, so here's an example right here. If we want to simplify 3x plus 6 over 6, we just take the top and the bottom and we simplify that however we can. And the top, with 3x plus 6, we can factor a 3 out. So that's the same as 3 times x plus 2. And the bottom, since it's a 6, we can say that's 3 times 2. So that means there's a 3 on the top and a 3 on the bottom. Well, what is 3 divided by 3? That's just 1. So you can cancel those out, because that means you're just multiplying by 1, and that doesn't change anything. So it simplifies to x plus 2 divided by 2. That looks easier to work with than 3x plus 6 divided by x. Now here's something, don't make this mistake, because you look at that and you say, wait, I've got a 2 and a 2. See, a common thought is that the 2 in the numerator and the 2 in the denominator can be canceled out, but they can't, because this one is connected to an x on top. That's an x plus 2. So since that's connected, you cannot take this 2 and cancel that 2 out. All right, so division cannot undo addition or subtraction, because we're dividing when we take the top and the bottom. But there's an addition in there, so we cannot do that. You cannot separate those x and the 2, because that's a term that's together. Oh, restrictions. There are some restrictions placed on rational expressions based on their nature. X is limited and cannot be all numbers. So if we were looking at this, 4x squared minus 16 over 3x, can you imagine any possible x that would not be allowed? Well, yes, because remember, for any fraction, you can't divide by 0. The bottom of a fraction cannot be 0. So any x that would make the denominator equal to 0 would not be allowed. So in this case, x equals 0. If we had x equals 0, then the denominator 3 times 0 would equal 0. And we cannot divide by 0. So for this rational expression, we can look and say 4x squared minus 16 over 3x, x cannot be 0. Here's another example. Let's find the restrictions on this and then simplify it. So it starts the same way. We factor the top, we factor the bottom. The top would factor to x plus 3x plus 2, because that would get you to x squared plus 5x plus 6. The bottom is a perfect square trinomial, because it's x plus 2 times x plus 2. So now that we have all the factors, we can see that there's an x plus 2 on top and there's an x plus 2 on bottom. So those cancel each other out. So it simplifies, just be x plus 3 over x plus 2. But x cannot equal negative 2, because if x was negative 2, negative 2 plus 2 would be 0. See, x cannot be negative 2. Since they're both x plus 2, it's the same x. So there's a restriction. But it would simplify to that. All right. All right, we're going to do this one on paper rather than watching the video. So the first one we need to look at is, how can we simplify the top and the bottom? X squared minus 12x plus 32. 32 is 1 times 32. We need a negative, though, so they should both be the same sign. Negative 1 times negative 32. 2 times 16, negative 2 times negative 16. So far, none of these add up to be a negative 12. All right, that's 33, that's negative 33. It's 18, that's negative 18. How else can we get 32? 4 times 8. That adds up to 12, but we need negative 12. Well, fortunately, negative 4 times negative 8 also multiplies together to be 32. So factoring, we know that this factors to be x minus 4 times x minus 8. Fabulous. Well, now let's see if we can factor this. What multiplies together to be negative 8? Well, we need it to add up to 7. So negative 1 times 8, 1 times negative 8. Oh, look, we've already found it. These add together to be negative 7. So this is the same as x plus 1 times x minus 8. Okay, so since it's simplified, we can go ahead and figure out what is not allowed. X cannot equal. If this is 0 or this is 0, since they're being multiplied together, that would make the denominator 0, which we cannot have. So if x plus 1 was 0, x cannot be negative 1. Because negative 1 plus 1 would be 0. X minus 8, what would make that 0? 8. So neither one of those could be. X can't be negative 1 and it can't be 8. So that's part of our answer right there. And when we simplify this, x minus 8 divided by x minus 8, that equals 1. So we can cancel those out. And it simplifies to x minus 4 over x plus 1. So if we're doing some math, this is a lot easier to work with than this that has two quadratic equations. However, still x cannot be negative 1 or 8. If we wait until we get to this point, we're going to miss the 8. We're going to say, oh, x can't be negative 1. Yes, but we're still talking about the original equation. And then the original equation, negative 1 and 8 are both a problem. Both are a problem. Let's see what they come up with. We can fast forward to the end of their video here. See that x cannot be negative 1, x cannot be 8, and they have the same x minus 4 over x plus 1 that we ended up with. Same thing. X minus 4, x plus 1 cannot be either of those. So you find these numbers when you simplify, when you simplify it, not simplify it, I'm sorry, when you factor it. But before you simplify it is when you need to determine what x cannot be. All right. Example 2, and this is the lesson summary. So this is the last example on this page. Ooh, look at this one. 2x squared plus 30x plus 88 divided by 2x to the third plus 7x squared minus 4x. And they want you to simplify it completely and identify any restrictions. All right, so let's look through this. They got 3 steps here, and they have several steps here. So submit to see if we're correct. So looking at the numerator, what is the greatest common factor? We've got a 2x squared, we've got a 30x, and we've got an 88. Well, the only thing I see, you can't take an x out, but you can take a 2 out of all of those. You can take a 2 out of 2, a 2 out of 30, and a 2 out of 88. Submit. Yeah, that's the greatest common factor we can take out of the numerator. Now, what's the expression of the numerator once we're factored out? Well, the 2 comes out front. So that would leave us with x squared. They've got the little squared for us right there. And then 15x and 44. That's it. 2 times x squared plus 15x plus 44. All right. Now factor the trinomial 2 times x squared plus 15x plus 44. What does that break down to? Well, we know it's x plus something. Oh, that's not a plus. There we go. And x plus something, because both terms are positive. And this is an x squared at the beginning. So we know it's x times x. But what two numbers would multiply together to be 44, but add together to be 15? Well, 44 is 4 and 11. And that adds together to be 15. Way to go. So it'd be 2x plus 4, x plus 11. So that's as simple as we can make the numerator. That can't factor down anymore. So now they want us to look at the denominator, just a little bigger up here. 2x to the third plus 7x squared minus 4x. We have a 2, a 7, and a 4. There's no common factor. But we have an x to the third, and we have an x squared, and we have an x. So all of those have an x. Yes, x is the greatest common factor. So then the new denominator would be x times 2x squared plus 7x minus 4. They already have the minus on there for us. Submit. Way to go. Now, what's it got? Now it wants us to factor the trinomial. The x is already taken out front. So how can we factor 2x squared? Well, one of them will be 2x, and the other be x. It's a minus 4. So it's either 2 times 2 or 4 times 1. And one of those have to be negative. Well, if we do a plus 4 over here, it'd be 2 times 4 is 8. And then we put a minus 1 in here. Negative 1 and the 8 will give us a positive 7, since it's a positive 8 and negative 1. Way to go. All right, so step 2. After we've done that, here's what we factored it down to. Now we have to identify the restrictions. X cannot be what? And there's 3 answers here. Here's the first one. If that x is 0, then the entire denominator is 0. So it can't be 0. What about 2x minus 1? Let me put that up real quick in case you're struggling with that. If 2x minus 1, if that equals 0, we add 1. We're just solving for x. 2x equals 1. 5 by 2. If x was 1/2, that would be a problem. So x cannot be 1/2. And finally, x plus 4. What would make x plus 4 equal 0? If x equaled negative 4. So let's see. Excellent. 0, 1/2, and negative 4. Okay, step 3. The last thing we could do, simplify the factor expression by canceling anything in common between the numerator and the denominator. So select the factor that cancels with the one that's highlighted. Well, it would be the x plus 4. There's an x plus 4 on top. We see there's also an x plus 4 on bottom. So those cancel each other out. And it ends up with 2 times x plus 11 over x plus 2x minus 1. And that's it. Take a look at the simplification. 2 times x plus 11 and x times 2x minus 1. X can't be 0, 1/2, or negative 4. If you need more on simplifying rational expressions, there's another example in the little box that you can click on. So it does let you have some more to look at. And then it has the lesson summary. The lesson summary is basically going to have the steps. So you start with this rational expression. First thing you do is factor it. So you factor the numerator and denominator if possible. That's step number 1. Step number 2, identify any restrictions. In this case, there's only one. X plus 9 is the only term in the denominator. So x cannot be negative 9. And then you simplify it. So there's your 3 steps. Factor, identify, simplify. X plus 9 cancels out. So this just simplifies to x minus 3. All of this big nasty thing here is really just x minus 3. Except for x cannot be negative 9. And you're thinking, now that's interesting. Why can't x be negative 9? Just for the fun of it, and I think I'm getting in the next lesson a little early. Let's graph this. X squared plus 6x minus 27. Plus 6x minus 27. Oh, I'm on the wrong screen. And that's a plus. Okay, and all of that is divided by x plus 9. So since all of that, I got to put it in parentheses. So all of that is divided by, and I'll put this in parentheses, x plus 9. X plus 9. Look at that graph. It's a straight line. You're like, wait a minute, we had a quadratic equation. How can that be a straight line? Well, it's simplified to x minus 3. What's the graph of x minus 3 look like? Oh, same graph. Look, it's the blue one. But what about this? X cannot equal negative 9. It certainly looks like x can equal negative 9. Let's zoom in here. I want to show you something. All right, here is the value of x. As we get closer to negative 9, look what happens when we get to negative 9. It is undefined. There's a hole in our graph. Because when we graphed that equation, we said x cannot be negative 9. And when you actually graph it on Desmos, there's a hole right there. It does not exist at negative 9. Interesting. A hole in the graph. So yes, it does not exist at negative 9. So that's why this part has to be added on there. It is the graph of x minus 3. Exact same graph, except for negative 9 does not exist. Okay, you have some practice problems you can look at there. Pages 5 and 6 have more practice for you. So you should do those. Drag the statement to the correct reason. 2 of the statements are incorrect. Ooh. So which of these work there? There's 1 of 2. Go to page 6. There's more. More practice. Let's see. Simplify this. So basically just work this whole problem. Simplify that to its simplest form and list any restrictions, and then you can check your answer right there. 1 through 5. So there's 5 problems there. All right, let's look at the assignment that goes with this lesson. Simplify completely. It gives you a rational expression. Where does it simplify to? Which one of those 4 choices? Another one, simplify completely. Simplify completely. Simplify completely, find restrictions. See, this one didn't have you find the restrictions. Now you have to tell what the restrictions are. So not only do you have to get the right answer, get the right restrictions. And then another one. All right, so that is 6.01, simplifying rational expressions. Let's look at discontinuities. Game over. I didn't even have to change how I was showing that because there was no sound with that. Yeah, the object of the game at the festival is to get the ball from one end of the maze to the other. If the ball falls in one of the holes, game ends. So a little demonstration. They tried to get it through and it fell into the hole right there. Perhaps you've seen these little Brents, little fun games with marbles. I like playing those. All right, so for this lesson, I'm going to say how are discontinuities created? What are ways that discontinuous points can be accounted for on a graph? And how are zeros identified? Okay, this one's going to be a little longer than 17 seconds, and I will need the volume for this. Here we go.
We're going to take a look at some things that occur with rational functions. Here we've got a rational function in the form of a fraction, and why might this be a problem? Well, what happens if the denominator ends up being equal to 0? The function will be undefined. So we need to make sure that we eliminate anything from our domain that could cause that sort of problem. So what do? Well, the easiest thing to do is simply take our denominator and set it equal to 0. Now if I solve this, I get x equals 1. Well, this means that a value of 1 for x will cause the function to be undefined. And so of course we have to leave that out of our domain. Now I don't see anything else that would be a problem, so in this case our domain is going to be all reals, except x is not equal to 1. All right? Let's look at another example. Let's look at f of x is equal to x plus 5 over x minus 3. Right? Now in this case we might be tempted to say, hey, we have the possibility of a 0 in the numerator, but that's really not a problem. 0 in the numerator just gives us a value of 0 for the fraction. We can graph that. It's a perfectly acceptable answer. The only thing we need to worry about is anything that would cause us a 0 in the denominator. So once again, we could set our denominator equal to 0. I think in this case you can see that a value of x equals 3 will give us a 0 in the denominator. And so our domain here is going to have to be all reals. X is not equal to 3. All right? Well, let's look at one more. F of x is equal to 4 over x squared minus 5x plus 6. All right, now this denominator is a little bit more complex, but the principle is still the same. Take the denominator, set it equal to 0, and solve. Now, at this point, this is just solving an ordinary quadratic. So if we can factor, that would be the easiest way to go. And I believe this one will factor into x minus 2 times x minus 3. Okay? And so we could set each of these equal to 0, and we would find that x equals 2 and x equals 3 are the values of x that would cause our denominator to be equal to 0. So in this case, our domain is all reals. X is not equal to 2 or 3. And these are of interest to us because they're going to be related to asymptotes.
Okie dokies. All right, so that was discontinuities. So graphing this function says let's graph x squared plus 2x over x plus 2. It says use the graphing software of your choice. So let's go ahead and put that on Desmos. X squared plus 2x divided by x plus 2. Okay, so there's the graph. Oh, look, it is a straight line also. It's linear when it's simplified. So you may need to customize your view, the graphing area. But anyway, theirs looks just like ours does. Look at that. It has origin of 0. Yep, goes right through the origin. You enter the graph, and this is what it looks like. Looks like it's a linear function with no breaks. But here's the problem. If we simplify this, x squared plus 2x, that simplifies to x times x plus 2, and the top and bottom cancel out, which means it's just the graph of f of x equals x. But what happened with that x plus 2? That's one of the restrictions where x cannot equal negative 2. Let's go look at our graph. What happens when x equals negative 2? And we'll get rid of those little bitty lines. I don't want the minor lines. When x equals negative 2, it is not defined because x cannot be negative 2. That's not part of the domain. The domain is all real numbers except for negative 2. This graph does not exist when x equals negative 2. So that's what they were showing us there. Just take another look at the graph. It says you may or may not see a hole in the line at negative 2, because that's the point there. But that's when we went and looked at it. We did see a hole there. Negative 2 is not defined. It says try adding a point at negative 2. Well, I probably can just because it's going to ignore that it's part of the line. There's where it is. I can add that point, but it's not part of the graph. So to be accurate, if you're graphing this by hand especially, this is what you would do at -2. Does that make it bigger? At that hole where x equals -2. Didn't make it bigger, it just made it go away. Right there at -2, you put a hollow circle when you graph that to show that, oh, it doesn't include this point. It includes everything up to this point. It's got -1.999999999. That's on the graph. -2 is not. So right there, we put a hole. So let's look at another example. When we have this one, when we graph it, x minus 4 is on the denominator. So it will not exist where x equals 4. So we would identify that right off the bat. We see x minus 4. X minus 4 is in the top and in the bottom. So that means there's a hole in the graph right there. There's a hole in the graph at x minus 4. And the denominator can't equal 0 right there. So this says it would be where the 0.41 is. So the point of discontinuity is 4, 1. If we graph it, when x equals 4, that's what the graph looks like. But when x equals 4, there's a hole right there at the 4, 1 point. So we use the open circle. And then find the zeros. The equation simplifies to just x minus 3. So x equals 3 is where it crosses. That's where it crosses the x-axis. That's where the 0 is. All right. And the lesson summary. So this was a shorter lesson because the last lessons where we talked about factoring it. This just talks about what we learned from factoring it. So we should be able to answer these questions. How are discontinuities created? If you have the same factor on the top and the bottom, x plus 4, that's a discontinuity. And you account for that by putting a round circle right on the graph at that point, a hollow circle. And how are zeros identified in the rational expression? It's where it crosses the x-axis. You just take the simplified equation, set it equal to 0. So a discontinuity is a point on the graph where the function does not exist. You can find it algebraically by simplifying the function and finding the restrictions. And you use an open circle on a graph. And then the zeros can be found by substituting, setting it equal to 0 using the simplified function. All right, there is one page of practice for you. So you can identify the discontinuities, the graph, and find the zeros. And it gives you, 5 different equations here? Yeah, you got 5 different equations. And you can click on them, and they'll give you the answers. But it's some good practice problems for you to try. All right, let's look at the assignment that goes with this. What are the zeros of this function? Notice it didn't say what's the discontinuities, not the numbers that are not allowed. What's the zeros? In other words, if you graph that, where does it cross the x-axis? So simplify it first, set it equal to 0, and solve. That'll give you the x-axis numbers where it crosses the x-axis. Now, where's the discontinuity? That's the x's that are not allowed. So with x plus 2 being in the denominator, that gives you a big hint. All right, this one wants to know what's the discontinuity and what zeros. Where does this cross the x-axis? So what point is not allowed? Where does it cross the x-axis? Which graph represents this function? Oh, you've got a graph that has a hole up here at 212. Got a graph that has a hole at -2, 0. Graph that has a hole at -2, -9. The graph has a hole at 2, 3. And the graphs are a little different. This one has a 0 of -2. This one has a hole at -2, so it doesn't have any zeros technically. This has a 0 at 1, and this has a 0 at 1. And then finally, the last question is another one. Which graph represents this function here? This one, this one, this one, or this one. So it looks very similar to the problem above in the choices. All right, guys. Rational expressions. So we're going back to what we've learned before. We never get rid of this in math, right? Whatever we learned before, we're bringing it with us. We throw it in our math bag, bring our math tools along with us. So a lot getting back into factoring this week. Factoring. Hopefully factoring's not the hard part for you. Oh yeah, I can factor. Great. Well, then the rest of this gets pretty simple if you can factor. So this is some good factoring practice, this unit. So there you go. If you need help with any of that, get with me. This is a B-Day Friday, so I'll be here in class on Wednesday for you guys. So if your grade's below 70%, go turn stuff in, get your grade up. But if it's below 70% on Wednesday, I'll see you in class, or if you have questions. But this is the last week before spring break, so don't wait till like Saturday to do this work, because that means your spring break doesn't start till Sunday. You should try to get everything done by like Wednesday or Thursday so your spring break can start early. You can have a bigger spring break than all your friends that are in the building. All those friends that hop on the school bus and come here, their spring break doesn't start till Friday afternoon. Yours can start earlier. Just get your stuff turned in. So, all right, guys, if you need any help, email me. I'll be here Wednesday. Otherwise, if I don't see you again, have a great spring break. I'll see you in 2 weeks after the wedding for me. So, see you guys.